Hello viewers, welcome to my channel Chemistry by ANR. In this session we are going to discuss about some methods of preparation of carbonyl compounds, some important name reactions. I know this chapter is a heavyweight chapter, but please don't take it here as a heavyweight chapter. It is as simple as all other units once you understand it clearly. Let me try to give you some meaningful moments in your busy schedule. So if you think that my video is useful, do like, share and subscribe and keep watching. I need your support and I will be happy if I can help you in your studies. Hello everyone. Let us start our discussion with preparation of aldehydes and ketones. That is, preparation of carbonyl compounds. The first thing that we can see is by oxidation of alcohols. Oxidation of alcohols mean 1 degree alcohol undergoes mild oxidation to aldehyde, which can undergo again oxidation to form carboxylic acid. Now people at times have the query why I'm writing the nascent oxygen. Actually I'm writing it just to show that oxidation has taken place. Now 1 degree alcohol can be oxidized by strong oxidation to carboxylic acid. But if we want to oxidize to aldehyde, then we can use PCC, which is known as pyridinium chlorochromate. It is known as pyridinium chlorochromate. Now, this is actually a complex which is formed by mixing pyridine with HCl and CrO3. When you mix this three, you get a complex which is known as pyridinium chlorochromate, and it is having a function of causing controlled and selective oxidation. That means only 1 degree alcoholic OH gets converted to CHO. So I can write RCH2OH showing this carbon to be 1 degree. And then if I use PCC, then it can get oxidized to RCHO, which is an aldehyde. Okay. So next, after this, by dehydrogenation of alcohol. Now, oxidation means addition of oxygen or removal of H2. Dehydrogenation means removal of H2. So here again I can obtain from 1 degree alcohol I can obtain aldehyde, or from 2 degree alcohol we can obtain ketone either by oxidation or by dehydrogenation. Okay, so this also I can say that 1 degree alcohol undergoes oxidation or dehydrogenation. Next, from hydrocarbons, we have two methods of preparation from hydrocarbon. One is by ozonolysis of alkenes and the next is from alkynes by hydration. Let us see them one by one. Now, ozonolysis means addition of ozone. So here we can see that alkenes C double bonded C system undergoes ozonolysis first by O3 to form a triozonide. This is the triozonide intermediate. Okay, so this is the triozonide intermediate, which again breaks down in presence of zinc dust and H2O. So hydrolysis with zinc dust H2O, ZnH2O. Then what happens? It breaks down. How does it break down? It breaks down in this manner. Okay. To form what? To form 2 moles of C double bonded O, which is a carbonyl. So as for example, let us see examples of ozonolysis of alkene. Suppose I take over here propene. So CH3 CH double bonded CH2 is propene, and I want to show ozonolysis. So what can I do? First I will give O3. So the moment I give O3, it will form triozonite as an intermediate CH3 CH. It is a double bond, so both the bond will be utilized for this purpose. Now again here there is a CH2. So two bonds are utilized like this. So this is a triozonite. And then hydrolysis, zinc and H2O, ZnH2O. So when I use ZnH2O, it breaks in this manner here, here and here. So we can say actually it is breaking in this manner. This bond is breaking and this is again breaking. So what am I getting from here? I am getting CH3 CHO. So I can write CH3CH double bonded O, that is acetaldehyde, plus CH2 double bonded O, which is formaldehyde, HCHO. So these are the two ozonolysis product. Now when I write ozonolysis product, if I want to write it directly, then what will I do? I will write number 1 O3 and then number 2 ZnH2O, and then I have to add on both the side of the double bond oxygen. So when I'm adding oxygen, this is CH3CHO, and carbon oxygen bond is formed by a double bond, and this is CH2O. So I am getting CH3CH double bonded O, that is CH3CHO, plus CH2 double bonded O, which is HCHO. This is the ozonolysis of alkene. After this, we can discuss about hydration of alkynes. Hydration means addition of water to alkyne system. Now remember one thing, that it happens in presence of H2SO4 and HgSO4. So let me show this reaction. Say I am taking ethyne, CH triple bonded CH. This is alkyne. Now H2SO4, HgSO4 here actually is the reagent. See, H2SO4, HgSO4. Let us see over here. Addition of H2O to ethyne in the presence of H2SO4 and HgSO4. So of course we need to mention that here H2O is there. That's why hydration, that is plus H2O in presence of H2SO4 and HgSO4. Here remember that you are going to add it in OH2 manner. So this side I had CH. Now adding CH H2 to it, I will get a CH3 and a single bond CH double bonded O. This is what I said. So if I use say unsymmetrical, this is a symmetrical alkyne. If I use unsymmetrical, say I'm writing CH3 C and a triple bonded CH. This is unsymmetrical alkyne. Same thing I will do. I will add H2O in presence of H2SO4 and HgSO4. When I do so, remember that OH2 is added in Markovnikov manner. So I will add O this side, which is not having any hydrogen, and H2 adding to the other side. So what will be the product? The product will be CH3 and C double bonded O. CH was there, getting H2 becomes CH3. So this is the product. Remember that for symmetrical alkyne, I can add it anyway, OH2 or H2O, any side, but for unsymmetrical alkyne, oxygen will be added to the carbon not having hydrogen. Since it is alkyne, I will say not having hydrogen, which is substituted actually. Next, moving to preparation of aldehydes. Preparation of aldehyde. This is actually a name reaction, Rosenmund reduction. It's a reduction of acyl chloride or acid chloride. So it can take place from RC double bonded OCl or ARC double bonded OCl. The example which is over here is of ARCOCl, that is benzoyl chloride. Undergoes reduction in presence of PDBSO4, or I will say sulfur quinoline. Now this is acting as a catalyst, hydrogen in presence of the metal surface that is getting produced using palladium PD in presence of BaSO4. Sulfur quinoline acts as a catalyst poison, and this COCl gets converted to CHO. It's a reduction. If I don't use a catalyst poison, then this aldehyde may get reduced to 1 degree alcohol. So this is a method of production of aldehyde from acyl chlorides, that is RCOCl or ARCOCl, in presence of hydrogen PDBSO4 or sulfur quinoline, and it is a controlled reduction. Why controlled reduction? Because we are controlling the reduction of aldehyde to further getting reduced to 1 degree alcohol. Next is another name reaction, which is a Stephen reaction from nitriles or cyanides. RCN can be written in this manner, RC triple bonded N. Now this is getting reduced to corresponding imine in presence of SnCl2 and HCl. Take it in this manner that both the sides of C and N, H is getting added in this manner. Reduction, so I'll say it is H2 addition. So when it is H2 addition, it is forming RCH double bonded NH. That is this, which is an imine. This is an imine. This imine is undergoing hydrolysis to form aldehyde. So let us see, this is forming reduction with H2 in presence of SnCl2 HCl. So what I got is imine, RCH double bonded NH, imine intermediate. This undergoes hydrolysis. So when it undergoes hydrolysis, remember to add it in OH2 manner. Then what I get out of this is RCHO. So I am getting RCHO over here. So this is Stephen reaction. I hope it is clear. Now, nitriles can also get selectively reduced by diisobutyl aluminium hydride or DiBALH, that is diisobutyl aluminium hydride. So that's why this is your diisobutyl part and this is aluminium hydride. So this is the formula. Second is hydrolysis, followed by hydrolysis, and it gives you selectively CN gets converted to CHO, and it is a selective reduction method using diisobutyl aluminium hydride. So much selective that it is keeping this C double bonded C system unaffected in the product, and it is actually reducing CN to CHO selectively. Similarly, esters are also reduced. See, esters are not reduced by sodium borohydride. We have seen this. But esters are also reduced to aldehyde with diisobutyl aluminium hydride. And this is your ester linkage, which is getting reduced selectively to aldehyde, of course, by the action of diisobutyl aluminium hydride followed by hydrolysis. Next, from hydrocarbon. So this part was preparation of aldehyde. First name reaction Rosenmund, second name reaction Stephen, and then selective reduction using diisobutyl aluminium hydride followed by hydrolysis. Okay, now from hydrocarbons, here we can see aromatic aldehyde, benzaldehyde and its derivatives. So what is benzaldehyde? Benzene ring along with CHO. This is benzaldehyde, or maybe any derivative of benzaldehyde. They are prepared from aromatic hydrocarbons by oxidation of methyl benzene. So see this. This is again another name reaction which is known as Itard reaction. I have already said in the introduction part that there are too many name reactions over here, and my suggestion to all of you will be, do prepare a separate copy for writing down, for jotting down all the name reactions in an index keeping manner. That means write the name of the unit, under the unit what are the name reactions you are getting, and inside the copy write the starting material, the finishing product and the conditions. Okay, so first, strong oxidizing agents. They oxidize toluene and its derivatives to benzoic acid. So it is oxidation of toluene to benzoic acid. Okay, so this is toluene. It's a CH3 over here. Now, however, it is possible to stop this oxidation. That means you are doing selective or controlled oxidation. Stop the oxidation at the aldehyde stage. Now, when I am telling stop the oxidation at the aldehyde stage, I want to carry out controlled oxidation method. This I can do. Okay, by using suitable reagents. Let us see what are those suitable reagents. One is chromyl chloride. Chromyl chloride is CrO2Cl2. It oxidizes the methyl to aldehyde. Okay, oxidizes the methyl group, to chromium complex. This is the chromium complex we can see, and which on hydrolysis. So this is the hydrolysis, you get corresponding benzaldehyde. So this is your oxidation step, CrO2Cl2 in presence of carbon disulfide, and this is your hydrolysis step where you are getting benzaldehyde. So this name reaction is known as Itard reaction, by which you can obtain benzaldehyde from toluene by Itard reaction. So next we can go to use of chromic oxide, that is CrO3, which is again an oxidizing agent which is used for a controlled manner of oxidation. So CrO3 in presence of acetic anhydride, we can see over here, undergoes hydrolysis again to obtain benzaldehyde. This again is a method of preparation of benzaldehyde from toluene, though I will suggest you to use this method, Itard reaction, which is much more famous reaction. By side chain chlorination followed by hydrolysis. This is a free radical method of halogenation where monochlorination takes place, because you are using 1 mole of Cl2 and here you replace 1 H by Cl. Again you use 2 mole. That means it is actually not by 1 mole because you are obtaining another Cl. So I will say first monochlorination, or directly you can write over here dichlorination. Okay, so it's a dichlorination using 2 moles of Cl2. So write 2 moles of Cl2H nu. So 2 Cl has come over here, followed by hydrolysis. So First again over here we can see side chain chlorination followed by hydrolysis to obtain benzaldehyde. So many methods are there by which you can obtain benzaldehyde from toluene. Yet I will say do try to remember ITAD reaction. Now benzene to benzaldehyde. Now some can say, why ma'am I can obtain toluene from benzene. Yes dear, you can obtain. You can obtain toluene from benzaldehyde by Friedel-Crafts alkylation. Use CH3Cl in presence of anhydrous AlCl3 and you obtain toluene by Friedel-Crafts alkylation. This method is what? What is the name of the reaction? It is Friedel-Crafts alkylation. And once you have got toluene, I told you 3 methods are there, but you use ITAD reaction. CrO to Cl2 in presence of CS2 followed by hydrolysis. So what will I do? From here to here, I will write number 1 condition, CrO to Cl2, chromyl chloride in a non-polar medium CS2 followed by H3O plus hydrolysis, which is ITAD reaction. So you can obtain this method as well. And if you use the direct method using COHCl in presence of anhydrous AlCl3 and CuCl, this reaction is known as formylation reaction also. It is known as formylation reaction also because formyl group is getting added CHO. And it has another name which is known as Gattermann-Koch reaction. So you saw Rosenmund, you saw Stephen, you saw ITAD reaction, now you are seeing Gattermann-Koch reaction. So do practice the name reactions. Again I am reminding. Next, preparation of ketones from acyl chloride. This is acyl chloride, okay? RCOCl is acyl chloride using dialkyl cadmium. This is your dialkyl cadmium. But this dialkyl cadmium needs to be prepared from cadmium chloride with Grignard reagent. Now, this is RMgX, which is Grignard reagent. Okay, so to Grignard reagent, when you use dichloro, or rather I will say cadmium chloride, CdCl2, you obtain dialkyl cadmium. Okay, so this is actually being prepared in situ. In situ means you are preparing dialkyl cadmium in the reaction mixture itself from Grignard, and now you use it with acyl chloride and you are going to get a ketone. Remember, in the ketone, 1 R is coming from the Grignard, the other R dash is coming from acyl chloride. Okay, so this RMgX, from here also you are getting this R in dialkyl cadmium. Okay, you are getting this R here. So if I say that you have to prepare, say CH3, C double bonded O, CH2, CH3, then how can I prepare it? I can prepare it by using, say, CH3 whole twice CD in presence of CH3, CH2, C double bonded OCl. And some can say, why ma'am, I can also get what? I can get it by using CH3, CH2 whole twice CD and CH3, C double bonded OCl. Yes, you are correct. But the reaction which will be favored will be less hindered acyl chloride. Next, moving on to nitriles. That means from nitrile. This is the nitrile linkage. So this is your nitrile. In the nitrile, you are using Grignard reagent followed by hydrolysis. So Grignard in presence of dry ether and hydrolysis. Do mention dry ether here, because you know very well that if you have moisture, then Grignard will give the hydrocarbon. Let us see the mechanism over here. This we can write in this manner. See, R here, R, C, triple bonded N is my alkyl nitrile. So C6H5, this part is delta negative and Mg is delta positive, just as it happens in Grignard. R-MgBr, if I can write, then obviously I'll write delta negative here and a delta positive over the magnesium. Okay, so now this attack is very important. Why? Because we can see that this will come and attack the carbon and nitrogen will open up. So here if I say RCN reacts with R-MgX or MgBr, say, then what will happen is this is a delta positive, this is a delta negative, this is a delta negative, this is a delta positive. So R- will attack the electrophilic site, that is delta positive, and nitrogen will have the negative charge, and so it will hold MgBr. That is what is happening here. Nitrogen is holding MgBr. Since one bond is opening up and it was a triple bond, so here you have a double bond remaining. And C6H5 or R- has actually attacked, and so you get the linkage here. Next, followed by hydrolysis. So when I say followed by hydrolysis, break this bond in OH2 manner. So what you will get is CH3, CH2, C double bonded O and a C6H5. So that is what you have obtained, propiophenone. Okay, so whenever you are seeing these reactions, try to understand, try to realize how the attack is taking place, why the attack is taking place, which is a negative center, which is a positive center. Then only you will be able to chalk out the reaction on your own. Else, it is not possible for any individual to memorize the reactions. Don't even try to. Okay. From benzene or substituted benzene, if you have to obtain ketone. Now this is again a named reaction, or rather I'll say special reaction, which is known as Friedel-Crafts acylation reaction. Alkylation means addition of R, and acylation means COR or COAR getting added. Now, if I can obtain this, then in presence of anhydrous AlCl3, this acts as Lewis acid catalyst. It acts as Lewis acid catalyst. Okay, so what is happening? See, if I say R, C double bonded O, Cl, reacting with Lewis acid catalyst AlCl3, what happens is aluminium in aluminium chloride is having less than octet configuration. So since it is having less than octet configuration, it can take the electron pair towards itself, and so you get RCO positive, an electrophile plus AlCl4 minus. So what is happening is you are getting RCO plus or ARCO plus. So this is a method by which you can obtain acetophenone. You can obtain acetophenone from benzene, or you can obtain benzophenone from benzene. What is acetophenone? This is a benzene ring, C double bonded O CH3. What is a benzophenone? This is the benzene ring. You have a C double bonded O and a C6H5 or another benzene ring. So these you can obtain by the method of Friedel-Crafts acylation reaction. Okay, so this example is quite important. Do check out this example. Okay, give the names of the reagents to bring out this. Hexane 1 all to hexanal, mane controlled oxidation. So you can use PCC for controlled oxidation. Cyclohexanol to cyclohexanone. So here again you can use CrO3. Why? Because when you are writing cyclohexanol, just see, this is cyclic compound and this is OH. How many degree it is, dear? This is a 2 degree. So 2 degree undergoes oxidation to give ketone. So you get cyclohexanone. The third one, parafluorotoluene to parafluorobenzaldehyde. Actually, the focus is toluene group getting converted to benzaldehyde. So obviously follow ETAD reaction. So here I will like to edit something like CrO2Cl2, of course, but in presence of CS2. Number 2, HOH. This is the reagent which is for ETAD reaction. The other one is also there, CrO3 in presence of acetic anhydride, but I will tell that you better use ETAD reaction for this purpose. Next, like the fourth one, ethane nitrile to ethanol. So nitrile to ethanol, you can use selective reduction method. So diisobutyl aluminium hydride is used, right? Now allyl alcohol to propanol. Selective oxidation. So again PCC. In this manner, see, butene to ethanol, ozonolysis reaction. So in this manner, you can practice the reactions not only by seeing the name of the reagents, by writing the reaction, chalking out the reaction. It will help you to remember. Write the reactants, write the products, mention the reagents, then only you will remember. Next, in-text question. This in-text question. Here it is. What reaction is this? This is R, C double bonded O, Cl. So it's yes. I think many of you will be able to identify. It is acylation, okay? Anhydrous AlCl3 is acting as Lewis acid catalyst. So the product will be, this is the benzene ring. You will get acyl group, C double bonded O, C2H5. So 3 carbon atoms are there. You know what is the name? The name is propiophenone. The name is propiophenone, okay? Next, okay, dialcadmium wala question. See, I told you this should be less hindered, so this is more bulky. So in that case, what will be the product? The product can be what? It can be, this is your C6H5 and a CH2 and a C double bonded O and a CH3. This is the major product. Along with that, you will get a CdCl2. If you forget it, let us go back to that part where you have seen. Just see R-COR. Remember, you are getting here R-COR. For that, I will say this is your R- this part, and this is your R. So you have actually got this as R dash, then CO, just a minute, it's not visible only. So you have got R dash over here, then a C double bonded O, and then R. Okay, so this is it. Next, Next is here hydration we can see. Hg2 plus H2SO4 actually means hydration. Whether you write H2O or not, it means hydration only. And it means HgSO4, H2SO4. So try to recall what I said. This particular example only I showed you. That the carbon which is not having any hydrogen will be having what? Will be having the oxygen. The other one is having H2. So what will be the product? Product will be CH3, C double bonded O, CH was there, 2 more H and CH3. Next over here, let us see CrO2Cl2. Whether it is mentioned carbon disulfide or not, it is CrO2Cl2 and H3O plus. So please don't forget to remember etard. So what will happen? No other change will occur. Only a simple change is bound to occur. What? This CH3 will get converted to, please guess, what? Etard reaction gets converted to CHO. And whatever was there was a nitro, will be remaining there as it is, undisturbed. Okay? So that's all for this session. We have discussed the preparation of aldehydes and ketones. Deliberately, I did not add on the preparation of carboxylic acid because that needs a different section of discussion. Thank you all of you for being with me in this session. See you in the next fruitful session. Till then, bye all of you.